In this video, I'm going to show you how to build an AI agent and deploy it as an API within Azure. I'm going to show you this step by step, and by the end of this video, we're going to arrive to a state that is represented by this architecture. So this AI agent is going to help with answering questions like finding the travel distance between two locations or finding the travel time between two locations, given the current traffic conditions. Okay, so let's get started. First step, we're going to build an MCP server. We're going to build two tools within this MCP server, and we're going to make use of the APIs from Azure Maps Service, for search and routes API. Okay, so for this step, we need an Azure Maps account resource. I'm going to also create a service principal that would be given access to the Azure Maps resource. And then I'm going to use the Azure Search and route Python SDKs. Okay, so let's go to the portal. So before we want to use this, before we want to build this MCP server, right? So we need to create the Azure Maps resource. So I've already created this Azure Maps account resource. So when you create this Azure Maps account, when you provision this within the resource group, right? So you also get a client ID. That is associated with this resource. So basically, there's various ways to authenticate and use this service. Microsoft Entra ID, the shared key authentication, and the shared access signature token authentication. In this demo, I'm going to use the Microsoft Entra ID way of authenticating and using this service. Okay. For this purpose, I also created an app registration. In calling it MCP server. So if you look at my app registrations, I've created an MCP server app, app registration with this client ID. Okay, and then for this Azure Maps resource, I've granted the service principal the Azure Maps data contributor role. Okay, so this is my service principal, which got created when I created the app registration, and then I've granted the Azure Maps data contributor role. So I'm going to use this service principal when I'm developing this MCP server locally. Okay, and coming to the Azure Maps, so basically Azure Maps provides a set of geospatial services. It offers various SDKs, for search, for route, for rendering, and then for geolocation as well. In this demo, I'm going to leverage the Azure Maps Search SDK and then Azure Maps Route SDK. Okay, so let's go to the VS Code. Okay, so let's see how what this Azure Maps offers, right? So what I did was I've installed the Azure Maps Search and Azure Maps Route SDK. I've also installed the MCP Python SDK, which I'm going to use it, when I build the MCP server, and then the other packages for Azure Identity and then Async IO HTTP packages. Okay, so let's go to the code. So I've imported the map search client and then maps route client from the respective SDKs, Azure Map Search and Azure Maps Route. I've also imported the route summary from the Azure Maps, route models. So this is the route summary class. And then I've imported the default Azure credentials class from Azure Data Identity. Basically, I'm going to use the default Azure credentials, which uses the environment credentials. So basically, what I did was I created environment variables, the Azure Client ID, which is the MCP Server app, the Azure Client Secret, and Azure Tenant ID within my local. So when I'm using this with the default Azure credentials, it's going to use those environment variables to as credentials. Okay, so I've defined two functions. One is a get geocode function, which takes address as a string, and then it returns the latitude and longitude. the geocodes basically as a response, right? For this, so basically, if you want to use the Maps, Azure Maps search, you know, service like the APIs, right? So you need to create a map search client. You need to pass in the credentials, which is the environment credential, like the service principal name. And then I also need to pass the client ID. So as I was saying, right, so whenever you create an Azure Maps resource, you also get the client ID. So I'm referencing that when I initialize the map search client. Yeah. And then I'm calling the get geocoding method of the search client. I'm passing in the address, and then I'm passing the response, and then returning the coordinates like the latitude and longitude. Okay. I've also created another function, get travel details, which takes origin, the destination. We need to provide the latitude and longitude of both the origin and destination. The travel mode. So currently, this supports three travel modes: car, bicycle, and pedestrian. And then use traffic data Boolean argument, right? So um, for this, right? So I'm creating the maps route client similar to the Azure search, the map search client, right? I'm creating the maps route client by passing in the credentials and the client ID of the Azure Maps account resource. And then I'm using the get route directions method of the maps route client, passing in the arguments to get the route summary details. Okay. Let's see this in action. So let me run this code with three examples. I'm going to run this get geocode function with two addresses, and then the route summary details by providing the geocodes of both origin and destination and the travel mode as well. Okay, so I have run this. I'm printing the geocodes for both these addresses, as you can see, right? So I have the geocodes printed, and I've also got the route summary details. So if you look at the route summary details, I got the length in meters, travel time in seconds, and other details as well. Okay, so let's validate, right? So if we copy this address, let's go to the code here. I'm using the latlong.net website here. I've already, generated the latitude and longitude. So if you look at this, right, so it's minus 96.805 as longitude, which is what you see from the code, and then 32.783, which is what you see in this code, right? So basically, we're able to, retrieve the geocodes by providing the address to the Azure Maps, APIs. Okay, so let's take this, right? So what I did was I created an MCP. So this module here would help with creating the MCP server. So I've imported the fast MCP class from the MCP Python SDK. I imported the Azure the Maps search client and the route clients from the respective SDKs, and then I've imported the chain token credentials, managed identity credentials, and environment credentials from the Azure identity. Okay, so since I have the environment variables, the Azure client ID, secret, and tenant ID as my EMB variables. Um, it's going to use the environment credentials. So basically, the chain token credentials, how it works is, it first uses the environment credentials. If the environment variables are not present, like the Azure client ID, secret, and tenant ID, it falls back to using the managed identity credentials. Okay. So this is the credential object that I created, and then I've created the MCP server here. I gave it a name as Azure Maps. It's going to run on port 8086 with a streamable HTTP path of MCP. Yeah, and then I created a geocode schema here. So basically, it would provide the latitude and longitude. I've also created another schema, the travel detail schema with travel length in meters and then travel time in seconds. Okay, so I'm going to use this schema, when I define the tool. So if you look at this code, right? So I've created a tool. I've named it as geocode tool, which references a function called getGeocode. It takes address as a string, and then it returns the geocode as the it returns basically the geocode, which is the latitude and longitude, right? So again, I made use of the Maps Switch client, passing in the credentials, the client ID of Azure Maps account, and then I'm passing in the address to the get geocoding method. I pass the coordinates, and then returning it from this function. Yeah, I've also created another tool called travel details, which takes origin with latitude and longitude, destination, geocode type, travel mode, user traffic data. So I've used it route client, get route directions, and then I'm passing the response and then returning just the travel length in meters and then travel time in seconds. Okay. And finally, I'm running this MCP server in a streamable HTTP mode. Okay. So let's run this and test it. Okay, so I've started the MCP server. So currently it's running on port 8086. Okay. So let's go to Postman just to test this. Okay. So have this MCP server running on port 8086. And the MCP is the streamable HTTP path. So what I would do is I would establish a connection. As you can see, I'm able to establish a connection, and then I could see two tools from the MCP server, the geocode tool and the travel uh, details tool, right? And geocode is expecting address as a string, and then travel details, right? It's expecting the origin, destination, travel mode, which only accepts three values, and then the use traffic data Boolean values, right? So I've copied the same address from previous example. Let's run it and see, right? As you can see, I'm able to successfully connect to the MCP server. I'm able to, use this geocode tool. I, I pass the address, and then I got the latitude and longitude as a response. Okay, so basically, we were able to create the MCP server. We ran it locally, and we leverage the service principle when we make when we access the Azure Maps account APIs, right? So that's what we did here. Let's go to the next step. So in the next step, we're going to deploy this MCP server and Azure App Service. Okay, so for that, we need an Azure App Service resource. Um, we also need to grant access to this Azure App Service to use the Azure Maps APIs. We also need to configure authentication, um, and then we're going to use this, my user account to connect to the MCP server and test it. Okay, so what I did was I created a Docker file. I packaged the MCP server code, and then I'm running it on port 8086 here. So I already built this Docker image. It's available here, the MCP server. Okay. So for this, right, so let's go to the Azure portal. So I've created a container registry called demo ACR US, right? So I push the Docker image here to this container registry. Okay. And then I also have the Azure App Service resource, have the Azure demo web app MCP. So this is my Azure App Service where I'm going to run the MCP server. Okay, so you already went in and configured the ability to pull the Docker image from the container registry. It's going to use the system assigned managed identity credentials, and able to pull this Docker image and then run it as a container. Okay, so basically few things that I did, right? So to make this work for the ACR, the ACR resource. I've granted the app service managed identity, which is the this here, right? I've granted the ACR pull permissions, right? So it's able to pull the Docker image and run it, right? The other thing that I did was if you go to the Azure Maps resource again, if you go to the access control, I've given the MCP server, like the Azure App Service managed entity, granted the Azure Maps data contributor role. Okay, so in my code here, right? So I've mentioned environment credentials and then my identity credentials. So when this MCP server, when the Docker container runs on the Azure App Service, it's going to leverage the managed identity credentials when it connects to the Azure Maps services. Okay, um, cool. So now I'm running this on the Azure App Service. One thing that I also did was I configured the authentication. So if you go to the authentication here, I've configured the app registration, the MCP server app that was showing you earlier, right? So I configured that here for authentication in order to use these MCP server as an endpoint, right? So I've also added these token values here. Basically, it references the same client ID. And then, I allowed the client applications. I've also added another client application, which I'm going to show you in a moment. So, and then, other details as well. Okay. All right. So this is running locally. And then if you go to the intra, you go to the enterprise app for the MCP server. I've done few. So basically, what I did was I said assignment required to S, and then go to the users and groups. I've given myself access to use this enterprise app. Okay, so let's go to the code. So now this MCP server is running on Azure App Service. Okay, so let's connect to it and test. Okay, so if I go to the postman, I have the MCP, I have the Azure App Service URL, and then MCP is the streamable HTTP path. Okay, so what I'm doing is I'm going to generate an access token. I've already configured the callback URL. So if you go to the app registration, I've configured the Postman callback URL, and then I also created the scope here, which I'm going to use when I generate the access token. Okay, so I copied. So this is my callback URL. Have the authorization endpoint, access the token endpoint. I pass the client ID, which is the MCP server app. Okay, and then the scope, which is the scope that I just showed you. Okay. So let me generate that access token. I'm going to I've already authenticated into Azure portal as the user. So now I have the token here, the access token. Okay, so let's go to, let's see what this contains, right? So go to this, we take this access token, right? So the audience claim is API slash the client ID, which matches with this token audience value. And then if you look at uh, the, the details of the user, right? So basically the access token is generated basically this uses my details. So I authenticated as a user when I generated this access token. Okay, so I'm going to use this access token. um, in here as an, I'm going to pass it as a beta token and then connect to the MCP server. So we're able to connect to this MCP server, and then we're able to list the tools from the MCP server. Um, let's test this MCP server again. I'm using the same address to test it. So let's run this tool, the geocode tool, by passing the address. And as you can see, I'm able to get the latitude and longitude for that particular address. Okay, so let's disconnect. Let's go back to VS Code. Okay, so basically we are able to deploy this MCP server on Azure App Service. As a remote MCP server, we're able to successfully connect to it and test the geocode tool. Yeah, so let's go to the next step. So the next step, we're going to build an AI agent. We're going to make use of the LLM from the GPT 4.1 model from Azure OpenAI service. And then this AI agent is going to connect to the MCP server and then use the geocode and travel details tools for tool calling. Okay, so I'm going to show you the AI agent, right? So let's go to the code. So for this this step, right? So basically, I've installed. You need three packages: the Langgraph, the LangChain OpenAI, and then the LangChain MCP adapters. SDKs, right? So in order to connect to the MCP server and convert these MCP tools into LangChain tools. Okay. Um, as I said, right. So I already created the Azure OpenAI service. If you look at it, right. So I have the Azure OpenAI service, and then I've created the GPT 4.1 deployment within Azure OpenAI service. Okay, I'm going to make use of this GPT 4.1 model. Okay, I'm going to use key-based API key to access this LLM. Okay, so let's go to the code. So I imported the Langgraph. So imported again the Azure Chat OpenAI, the MCP, the multi-server MCP client from the LangChain MCP adapters, and other classes from the the Langgraph SDK. Okay. I've also installed opentelemetry packages. I'll explain that in some time. So basically, so now this MCP server, I'm going to use a multi-server MCP client and then pass these connection details to to the MCP server running locally. I'm going to get the tools from the MCP server. I've initialized the Azure Chat OpenAI LLM, so by passing the deployment name, and then this Azure Chat OpenAI allows us to bind the tools as well using the LangChain interface, like the standard interface, right? So I'm passing the tools, it's creating the LLM with tools, basically to enable the tool calling. Um, and then I'm creating a dictionary that basically has a name as a key and then the tool as the value. Okay. And then I created this agent state here, right? So basically what this does is I'm creating messages, which is a sequence of base messages. And then I'm using an operation here called add messages. What it does is, so basically state object is something that the land graph uses. When you create a graph, all the nodes of that graph can access the state. Um, they can either use the values from the state or they can also update the state as well, right? So since I'm using these add messages, whenever an updates are made to the state, those are appended to the messages. Okay, the messages variable. Okay, so this is one key thing within LangGraph. And And then I've created a function called tool node. I'm passing in the state here as an argument. What this tool does is you know, um, it looks at the last message from the state, and if it finds tool call, it's going to run. It's going to invoke in async mode by passing in the arguments from the tool call, and then by using the tool name from the tool call message. Okay, and once it executes its tool, it responds back with a tool message. Okay, and then it returns the output of the tool message here. Okay, if there are multiple tool calls, it's going to do that in a loop, and then returns the messages. Right, when it returns the message, basically what it does is what Langgraph does is it adds that message to the messages variable. I've also defined another node called call model. Basically, what it does is it calls the LLM with the system prompt and the state, which contains the messages. And then once the response, once the response is received, it appends to it to the state. Also define another function called should continue. Basically, this acts like a conditional edge, which determines whether to end the graph or whether to continue the the flow. Yeah. Okay. And finally, I'm creating the graph by by we created a graph instance here. I've added the nodes. I've added agent node, which references the call model function. I've added another node called tools, which references the tool node function. I've set entry point as the agent node. And then this conditional edge, basically, it starts with the agent, like the LLM, and then it runs the should continue function, right? If there is a tools call from the LLM response, it goes to the tool node. Otherwise, it ends. Okay, it ends the workflow here, right? And then I've added another edge here. So once the tools call is, tools execution of tools is completed within the tool node, it goes to the agent node again. So before you want to use this graph, you have to compile it. Okay, so I already did that. Okay, so basically what I did was I created an agent node, I created a tool node, and then there is an end node here. Okay, so agent node would take the user request at the beginning because it is the start node, and then the LLM would respond back. If you since we are binding the tools to this LLM already within LangChain, right? So when we send this when we call the LLM with the user prompt, the LLM would say, okay, if there is a need for calling the tool, it would say, it would pass the arguments and then the specific tool name in the response. If that tool name is present, it would go to the tool node. It would execute the tool. Once the execution is completed, it goes back to the agent node. And if there is no tool call, the workflow ends here. So that's what we did here by defining the various functions. Okay. And then, just this, right? So what I did was I created an input message. Basically, I said, I would like to travel from Dallas Aquarium to San Antonio SeaWorld. Could you please help me with an estimate of the travel distance and time? Okay. I'm going to, stream this with stream mode as updates. Basically, whenever an update is made to the state object, right? Um, all of that is going to be streamed when I run this way. Okay. So let's run this. I've already, passed the responses from the state, so you understand how this works. Okay. So I'm running this by passing the user input, right? As you can see, um, for that question, right? So what it did was, first it went into the agent node. The text content is not text content, but the LLM returned with, um, you know, two tool calls here, right? It said, call, you make use of this geocode tool with these arguments, right? It uses, basically the LLM was able to parse Dallas Aquarium and then convert that into Dallas Aquarium, Dallas, Texas. Okay. And then it also, for San Antonio SeaWorld, it said, SeaWorld, San Antonio, Texas. Okay. So it, the LLM came up with this response. Okay. And then it went into the tool node. The tool calls were made. So basically for geocode tool, these are the arguments. And then for um, the other tools, the geocode is a tool with these arguments, right? So you're able to run the tools, both the tools, and then it goes back to the agent, right? Because we have the H defined from tools to agent. And then the LLM came back with a response, right? Saying, make call this travel details tool with these arguments, right? So it, you know, took those latitude and longitude, and then, it converted into origin, destination, and then travel mode as car, and then use traffic data as true, right? So this is the LLM response. And then, since we have the tool call, so it goes to the tool node. So the tool node is executed, and it came up with a response, like travel length in meters and travel time in seconds. Okay. And then it goes back to the LLM, the agent node, and then the LLM responded back with an answer, right? It said, the estimated travel distance is 462 kilometers. So basically, it was able to convert the meters into kilometers and miles. And then it also said, the estimated, time to travel is about 4 hours and 24 minutes. Okay. And then, it also responded, well to the user saying, if you need more details, right? So basically, this is what happened with this Langgraph. Okay. So yeah, there's a lot of, since even though this is a simple tool, right? So basically you see, right? So there's a lot of back and forth calls between LLM tools, for this user question, right? Um, let's go to the next step, right? So in the next step, what I did was, we printed the responses from the LLM, the responses from the tool node and all that, right? But there is a better way. We can make use of some OpenTelemetry SDKs. So basically what I did was I installed the OpenTelemetry API and SDK, the OpenTelemetry protocol exporter. I'm making use of the OpenInference, LangChain, and then OpenAI instrumentation SDKs, and then have a Dagger Docker container to see the actual calls, right? So let's go to the same Python module. Okay, as you can see, I've imported the Open Inference instrumentation library. So basically, you go here, right? So there is AI provided these Open Inference. These are open source libraries. So I'm making use of the Inference instrumentation library, and then the Open Inference instrumentation LangChain library. Okay. I've also installed the OpenTelemetry SDK, OpenTelemetry API. I also installed the Azure Monitor OpenTelemetry exporter, which I'm going to use it when I build the API. Okay, and then so then I imported the span processors as well. The OpenTelemetry exporter and all that. Okay, so let's uncomment this. So I created this resource. I gave it a agent stateless as a name, And then, I created the tracer provider object, and then I set the tracer provider for the OpenTelemetry API. The tracer. Two processes here. One is a simple span processor. So basically, all the telemetry data would be, processed by this simple span processor, and then, it would export that to the console. And then I have another span processor, which is going to export into this endpoint. Okay. So before we go there, right? So let's go back to the open telemetry. So I'm on this page from open telemetry docs. And if you go to Tiger, right? So I can run this container on my local. So let's go here. Let's run this Docker container. And as you can see from the docs as well, right? So this is the UI is accessible on port 16686, and then the open telemetry protocol, like the endpoint is on port 317 and 4318, right? So basically you have referenced the same in this OTLP span exporter. Okay, and then I'm going to do the auto instrumentation. Okay, I'm going to run the same code but with this auto instrumentation enabled. So let's run this. Okay. So you see a lot of spans here because I've configured the console span exporter, but at the same time I also have the traces exported to the Jaeger backend. Okay, so let's go to the Jaeger backend. So it is running on port 16686. So this is our service name. Let's click on find traces, and then you're able to see the traces, right? So as you can see, right? So basically this gives a visual representation of what happened when we run the graph node, right? So it again, as you can see, right? So the initial call was to the Azure, like the LLM, and then uh, you can also see a lot of details here, right? So the 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 prompt that was sent to the LLM, as well as the response that you get from the LLM. Okay, so there's a lot of details here. So if you go to the output, right? So basically it said, tool calls, call this tool for dollars aquarium, right? So all that details is being, um, captured here in these traces. And then, it goes to the should continue node, right? Since there is a tool call, the output would say continue, right? And then it executed these two tools, and you can see it executed the first tool, and then you can see the output value as well, right? And then it went to the LLM again, and then LLM responded with a tool call, so it continues the execution, right? So and then it this is the it used the travel details um, tool. It passed these arguments as input values, and then it got the response, right? And then it goes to the LLM again, and then you get the response, right? So you can see the complete picture here with traces. Yeah, all we did was install the openinference Python SDKs, OpenTelemetry SDKs, and then we did the auto instrumentation, right? I mean, there are ways to do manual instrumentation as well, but I think the the auto instrumentation did a good job for us, at least in this example. Okay, let's go back to our diagram. So basically, this is the agent node, and then with OpenTelemetry traces, right? So We have the traces already, and then we're using the span processor with exporter, and then it is all sent to the backend, which is Hager in this example. Yeah. All right. So let's go to the next step. The next step, we're going to convert the AI agent code as an API. Then we're going to connect to the MCP server running on Azure App Service. Then we're going to also use the Azure App Insights for the observability. This becomes our backend system for capturing for storing the traces here. Okay, so let's go back to the code. So I already created a class. So basically the same code I've converted into a class here. And then if you go to the code, so I've also imported, at least in this here, right? So I've removed the console span exporter, and then I've only kept the Azure Monitor place exporter. Okay, I'm I'm doing the auto instrumentation here. I defined a function called JWT factory, and then I'm using the chain token credentials, environment credentials, and then manage entity credentials. So um, basically what I did was, right, so in order to connect to the MCP server, right, I created a service principal. I created an app registration. I created this app registration. Okay, and then if you go to the MCP server app registration, I created an app role called read dot all. Okay, and then for this agent API, I configured the permissions. Yeah, so by doing this, what happens is go to the MCP server app enterprise app. You see this agent API service principal. Okay, so we can use the service principal to connect to the MCP server running on Azure App Service. Okay, um, I've already copied the Azure client ID, the client secret, like for the agent API, the MCP server URL, and all that details here. Okay, and then basically I'm creating the credential object. So basically, it's going to leverage the environment credentials here, and then it's going to use the MCP server ID. It's the client ID of the MCP server app registration. It's going to generate the bearer token here. It's basically I'm creating the HTTP async client, and then I'm passing it to the multi-service MCP client connection. Okay, so basically this is going to be more dynamic. And as you can, I've also created the LLMs using the Azure Chat OpenAI. I'm getting the tools. I've initialized the agent graph object, from that agent graph class. I'm going to build the graph. Now, this is going to be passed to the fast API, the lifespan function here. Okay, and then I've created two endpoints. One is a root endpoint, which just returns with a message. And then I've got another endpoint called agent, which takes the user input as a string. Okay. And then it, provides a streaming response, as you can see, right? So I'm calling this um, graph.async stream method here. I'm passing in the inputs, and then, the stream mode as messages. I'm only going to send the response from the LLM. Okay, so let's run this locally. As you can see, this is running on port 8086. So we're able to hit the root endpoint. And as you can see, right, so I have these two endpoints, the root endpoint as well as the agent endpoint. And this is what you need to pass. Yeah, let's go to Postman and test it. So this is the API running locally. and this is the endpoint. And then I'm going to pass, the user query. We don't need to we don't need any bearer token because it's running locally. Okay, we're able to connect to the API. So, as you can see, we're able to get the response from this agent API. Okay, so one thing that we did here is we also configured the Azure Monitor trace exporter, and then we added it to the BANX processor, and then add it to the tracer provider, right? So by doing this, uh, we were able to so let's go to the application Azure Application Insights resource here. So this is the App Insights resource that I've used. If you go to the transaction search, okay, so this is the full page, right? As you can see, right, this looks similar to what we saw from the Azure endpoint, like from the Azure UI, right? Um, but this is currently within Azure Application Insights. As you can see, right? So we see the calls to the LLM, um, the should continue conditional edge, the geocode tools, right? So the inputs and the output values, uh, even from the travel details, tool call, and then the response from the LLM as well. Yeah, all of that is captured here within Application Insights. Okay, all right. Go to your diagram, right? So basically, we're able to create an API. We're able to run it locally. And then we were able to emit the traces to Azure Application Insights. And then we're basically be connected to the MCP server that's running on Azure App Service. Okay. In the final step, basically, we're going to take this fast API. We are going to deploy it as an API within Azure App Service. So for that, we created a Docker pipe. I copied the Flask the fast API code, which is in the pipe, the main.py module. I packaged this already, and then I pushed to the same Docker image, same container registry. Look at the repositories. Have the AI agent API pushed to this Docker image. Okay, and then I've created an app service called Agent API. Similar to the MCP server, right? So I configured the managed entity, the ability to pull the Docker image and then run it as a container. One thing, so the MCP server, like the Azure App Service, was using the managed identity credentials when it connects to the Azure Maps resource. But in this case, we're leveraging the Azure client, like the service principal names, to connect to the MCP server, right? If you go back, right? So basically, we are using the service principal to connect to the MCP server. Okay. And one thing that I also did was I also configured the easy auth for the Azure App Service. So go to the authentication. I configured the app registration. Same as what you saw for the MCP server running on Azure App Service, right? So I've configured the allowed token values, and at the same time, I've also um, go to the properties. I said, user assignment is required. And if you go to the users and groups, I've, given myself access to call this API endpoint. Okay. And then one other thing that we also did was if you go to the um, MCP, like the Azure App Service, where we have the MCP server, right? Within authentication, we have two clients here, right? So one of them is the agent API. Okay, because the service principal. Um, is going to generate the access token and then connect to the MCP server, right? So we have this client ID. Even in our previous example, where I was connecting to the MCP server, um, right? Basically, we were able to achieve this because MCP server also accepts the tokens from another clients as well. Okay, let's go to this. So now we have the agent API deployed. So let's test it. Okay, so again, I'm using the auth code with the PKC grant type. I have the callback URL already configured within the agent API. Have registration. Okay. Um, and then I have the scope as well for the read.all. Okay, so which I showed you earlier, right? So go to the app registration, agent API, API permissions. We have this scope, okay, the read.all, and this is what I'm using here to generate the access token. Okay, let's get the access token. Okay, let's copy this. Let's go to for the DWT token. As you can see, this is my audience screen. This is what you see here for the Azure App Service, the agent API. So if you go to the authentication played, you can see the allowed token audience, right, which matches with what you see here, right? And basically, this is generated after I, authenticated to Microsoft Entra. Okay. So I'm leveraging this access token, and then I'm going to call this agent endpoint running an Azure App Service. Okay. So I have this, agent endpoint here. I'm going to use the, Pera token, which I just generated with this user input, right? So basically, my question is, how many days does it take to walk from Las Vegas to Seattle? So let's run this. As you can see, it came up with a response saying, it takes about 15.9 days to walk from Las Vegas to Seattle. It assumes that continuous walking at an average pace and does not include break for rest. And if you walk about 8 hours per day, that journey would take about for 48 days. Okay, so this is the response that you got from the agent API. So basically, what we did in this demo is we're able to build an MCP server, with two tools. One that converts an address into geocode. The other one takes the origin and destination geocodes and other details and then provides you the travel distance or the time to travel as well, right? So we have created an agent using Langgraph framework, right? And then, we made use of the GPT 4.1 model from Azure OpenAI. We built this agent. We deployed this agent as an API within Azure App Service. We also configured observability to capture and export the traces to the Azure Application Insights. And then we are able to, connect to the agent API by using the Beret token, right? The Azure App Service was using the, manager entry credentials to connect to the search and routes API, the Azure Maps, resource, and then the agent API using the service principal to connect to the MCP server, right? So, so yeah, and then we are able to, ask questions like, similar to this, and then get the response. All right, cool. Thanks for watching.